There we go. OK, awesome. Thanks. All right. Hello, everyone. I would like to start with a quote, which is one of my favorite quotes on, on software development. And this is, clean code reads like well-written prose. And I like to write clean code, and I think that it's important because maintaining code is actually a big, if not the biggest, cost of actually writing software. We spend most of our time reading code and updating existing code. So by making the code clean and by making maintainability easy, we're actually making this writing software thing that we do cheaper. It's not only about the economics. Developer happiness is also very important. We want to be happy. And maintaining code that's easy to maintain, it makes our job much easier. And also, if we can modify the code much faster, we can iterate faster on our products. So that is also an important thing. So let's say that you have your code, and you have to add a feature or a concern to this code. And, well, you decide that there are just a few lines, it's just a small thing, so I'm just going to go ahead and make room for it, add a few lines, and it works. And don't get me wrong, this might be the right thing to do. This might be the most cost-effective way of getting this thing out the door. Nothing wrong here, necessarily. Now, 2 months down the road, you find out that, well, you need to modify this code because the customer wants to iterate on this, or business, or whatever. And, well, you now go ahead and put the time in actually extracting this code out and create this reusable piece, this abstraction that now you can test in isolation, you can share, etc. So this is good. We know this. We do this all the time. Let's see an actual example. Let's say, for instance, that we have a class, for instance, models a subscription where the user is paying. And we can see that the initial state is pending, and you can then activate it with the code only if it's pending. And the user can suspend the subscription only if it's active, so you will stop paying. Simple example, right? So let's say that this whole state thing is the thing you added. Now, when it's time to extract this, because you want to iterate on this faster, you will create something like this. You will extract, and you decide to solve this problem as a state machine. So you might, for instance, create a state machine class, a state, event, transitions, and you put all these things together and to model whatever you're trying to solve. And now you can reuse this state machine for other things. So that's great. Let's see how we can take this to the next level in the maintainability realm, if you will. So we're going to be talking about how to write DSLs in ObjectiveC. My name is Luis Solano. You can find me on both Twitter and GitHub. This is my username, Luisobo. And even though I've been working with the iOS SDK for around 4 or 5 years, that's not the only thing I've been doing. I've done a lot of Java, Ruby on Rails, playing with Scala, different languages. And I've seen a lot of patterns in other communities, like domain-specific languages, that are really useful. And I would like to import them because you don't see many DSLs in Objective-C to our community. So DSL stand for domain-specific language. And what that means is, domain-specific language is a language. But it's not only a language, it's a programming language because we use it to tell a computer what to do. And it has, programming language nature. It has a structure. And this language is a specific, read-constrained to a certain type of problem. So you solve one type of problem with one DSL. And it has limited expressiveness. You can say only a few things with the DSL. And it has this domain focus in one specific thing. In our example, state machines. So this domain focus is what making the DSL worthwhile. So let's actually see how it will look like. So if we have this abstraction that we see earlier, we can actually put a small layer on top of it. That will be the DSL. That will make it, it will give this fluidity to this API. So we can convert something like this, that it's just adding a transition to a state machine, to something like this, that reads much better, in my opinion. You can see how it's more fluid, and it reads much better than a classic imperative method. So this is actually part of an open source project of mine. And I'm going to be using my code as example. That comes in handy. You can find it on GitHub. And that was just one line. But how you define a whole state machine, it looks something like this, right? So you want to define a state machine. You can set the initial state. And then you set what are the valid transitions for given events. So when you want to activate, you can go from pending to active. Or the last two lines for the when is when you terminate, you can either go from active or suspended to terminated. And you can also define callbacks to be executed before and after events are triggered, right? So this is all declarative code, and it reads much better than if we have to multiply that imperative code multiple times. So we have this. Let's focus on this reusable part with the DSL. Again, the DSL is a thin layer on top of the underlying abstraction. So the DSL sits on top, and what's underlying, it's called usually the semantic model. The semantic model would be our state class or event class, et cetera, right? It depends on your domain, but this is our example today. It's important to know that there has to be a separation between the domain-specific layer and the semantic model, just so we can work on them independently, iterate on them independently, you can test things independently, and you can have different domain-specific language implementations for the same semantic model, as we'll see in a minute. Another important trait of domain-specific language is that they're declarative, as I mentioned. So declarative programming means that we express what we want instead of expressing the steps to follow in a specific order to achieve what we want. That will be imperative programming. So imperative is, this expression telling the computer, do this, do that, do that. And, imperative is fine. Imperative actually works. It's actually the only way we have to tell a computer things. The problem is not with imperative per se. The problem is with my brain. It's with our brains. You can say that, my brain cannot handle imperative programming scale. When a program grows, if you keep doing it in an imperative way, you're going to have a bad time. So yes, an DSL is declarative. And another example of declarative programming could be auto layout. We know this one. You express with constraints how your views are put together, and the system will figure out how to actually make that happen, even if you resize the view, right? Reactive Cocoa, awesome library, by the way. You express with Reactive Cocoa, it's not a DSL, but it's declarative, how your data flows in your program, and it goes and figures out how to make that happen. SQL, hey, I want this data, and the system goes and figures out how to retrieve it. So declarative is definitely a way to go. Now, there are two types of DSLs, two main types of DSLs. The first one is external DSLs, and given an application, in our case, an iOS app, for instance, it's written in Objective-C. That would be the main language. External DSL is a language that's separate from the main language of the application. So it uses a custom syntax that you have to use parsing techniques to parse and interpret and react to it. Or you could use, instead of a custom syntax, another syntax. For instance, you could use XML. We can discuss whether it would be a good thing to do, but this is an example, right? So when Java people say, oh, we write a lot of XML, is that they basically using a DSL, a pretty bad DSL, to things that they cannot do with their language. So this is definitely doable in DSL. You will, for instance, add a build phase to your build process, and we'll take the files that are instead of .m, whatever you decide, and it will, for instance, take these files and compile them to maybe Objective-C code, and then you can put it along with your binary. Or you can load these files at runtime and interact with them. Basically, you will ship an interpreter with your binary. For a small language, that's not a problem. So two approaches. But today we're going to be talking about the other alternative, which is internal DSLs. Now, internal DSLs are basically a special way of using a general purpose language, like Objective-C. It's valid Objective-C. We're just putting it in a way, as we saw earlier, that looks like more a language, though more than a specific language, more than a general purpose language. Good. So why to write a DSL? Well, as I mentioned earlier, economics, it's a good point. But there is also open source. So that doesn't necessarily involve economics. But making the code more maintainable is always something good. Developer happiness. You can actually write fewer bugs when you use declarative code, something like a DSL, because that you're limited into the things. You're limited with the things that you can say by the DSL. And last but not least, you improve the communication, and I think this is huge. If you think about what we developers do, we basically are filling a communication gap, right? We have, on one side, we have our product manager, maybe, or customers, or users, and on the other side, we have a computer or a phone. And these guys over here want to tell a computer to do something, but they don't know how. So we're in the middle saying, OK, what do you want? OK, I know how to tell a computer what to do that. So we fill this communication gap. Now, we have to cover this gap, and we cannot tell people over here, hey, lower your level of abstraction of your talk all the way down to the computer level and basically learn how to code, because they will be doing our job. What we could do instead is raise the level of abstraction that a computer can understand. So instead of a computer understanding if statements and add this to that, et cetera, we create constructs that are higher level. And then we effectively closing the gap between these people over here and the computer. That doesn't mean that our job is going to disappear. If we actually close the gap, that won't happen. But it will make our job much easier. So this is important. Now, when to actually create a DSL, right? It doesn't make sense to create a DSL for everything. When you expect to have a return, and in the form of the things that we discussed in the previous slide. So, a few hints, is if you have a certain part of your code that you have to modify a lot, well, that might be a good candidate to write a DSL for. If communication is hard with stakeholders, or there is some kind of communication barrier, it could be a good idea to write a DSL for that. Or even if it's a critical part of the system, because if you can express and change the system in a declarative fashion, it's less likely that you make mistakes. Now, we're going to talk about how to actually implement a DSL. And again, we're going to be doing it an internal DSL, or see techniques to implement an internal DSL in Objective-C. So this is actually going to be a series of tips, tricks, techniques, whatever you want to call it, on how to reach a few corners of Objective-C syntax and twist it, bend it to your will to create a DSL. Now, the first one, and it's probably the most basic technique, is a plain Objective-C method. We're pretty lucky because in Objective-C, we have this message passing syntax where we interleave the name of the method with the arguments. That's borrowed from Smalltalk. And it comes in handy when you want to form a sentence. It's pretty cool. It's very basic. But we're familiar with it, so we can use it. Now, I'd rather have, as I mentioned earlier, this line of code than this a line of code. So this is how you compare the two versions, right? So this will be forming the underlying graph of objects with states and transitions, et cetera, that will make our program actually work the way we want. Now, Objective-C methods are good, are simple. The problem is that they're limited by, you can only form sentences of a given size, of a fixed size. In this case, it will be, 3 particles of a sentence. As an alternative, we can use what's probably like the workhorse of internal DSLs, and that is method chaining. This is Kiwi, the testing framework. And what it does is basically you call a method in an object, and that returns another object that you call another method, so on and so forth. So every method modifies the underlying semantic model and returns self, so we can keep calling methods and then form a sentence. Now, it's important to say that you can leverage the type system to actually to only let the user say things that are valid, right? So for instance, you couldn't call equal on the state object. You can only call it in the thing that's returned by the should method. Now, method chaining with the Objective-C syntax is good. Now we can have like sentences with variable parts. That's good. The problem is that with long sentences, we have to pay the tax of the open square bracket at the beginning. And for sentences that could be as long as you want, that could be a pain. So to avoid that, we can use method chaining with the dot notation. Now, this is valid Objective-C. It can be a little bit weird to understand at the beginning how this is put together. But this is another open source framework I wrote to stop network requests for testing purposes. So you tell it, OK, I want to stop. If the code makes a request to this URL, return this fake response, right? So you don't actually hit the network. And the way it works, the way it's implemented is, the entry point, stop request, is a C function that returns an object that has the method and return. Now, the and return method doesn't take parameters. It's just no parameters, and it returns a block that takes an integer that returns self. OK? And self has also with body that doesn't take arguments, returns a block, takes a string, returns self. And you can keep going, right? OK. So now we can have sizes of, sentences of this size, and any size, without having to put square brackets at the beginning. Now, that doesn't have to be that complicated all the time. You can use simple things as well. And you can use, like, now that we have them, simple literals like array on dictionary, you can use them in your DSL. For instance, here I'm using, if you want to specify a set of headers, instead of calling with header, header key, header value, with header, header key, header value, you can pass a dictionary. So there's that. Another tool is macros. Now, some people don't like macros. I don't like it for the usual development that we do, but it's a useful tool for writing DSLs because it allows you to actually do text manipulation with your source code. Textual manipulation is good for this type of things. So if you think that plain C macros are cool, you should check metamacros.h. And these are some special macros that is defined in libx Objective-C, where you can do things like concatenate strings. You can do ifs. You can do iterate a list of arguments. You can take the first argument of a list and the tail, et cetera. So it's definitely really powerful. And we're going to see how macros can help us in a minute. But sometimes there's this question, where do I put my DSL? So sometimes it's clear where a DSL goes, where to actually use it. If it's a test tool, well, I go with our test. If it's, for instance, the state matching example, it goes to state matching for a class, so maybe we can put it with the class. But some of the times, our DSLs describe like universal truths of how our system works. For instance, I have this other open source framework. Sorry for the shameless self-promotion, where you can build test objects. You define a factory for test objects, and then you can later on retrieve these test objects for testing purposes. This library has two parts, right? First is a DSL, where you actually define the factory, and the second is where you actually request a test object. Now, the second part is it's trivial where to put it. It goes with the test. But the first part, where do we put it? Well, because it's a universal truth, isn't it's how you build a test object for this particular class. Where do you put it? Not with this class because it's production code. Not with a specific test because, why with this test and not the other? I can use it in many. So what you could do is define what I call an entry point for DSL. And basically, this is a macro. And you can put this in an empty .m file, not that it's required whatsoever. And you put your DSL inside this, the curly braces, and it just works. No classes involved, and it's magic. Now, this macro actually expands to something like this. You might know this is a plain C function annotated with attribute constructor. And this is telling the system that as soon as the binary is loaded, please call this function. So as soon as the binary is loaded, your DSL will be evaluated. It will pull your semantic model together for later use. Now, there is a small problem with this, is that if we use the same function name and we want to use that factory macro multiple times in maybe multiple files, you will have a compiler problem because the symbol, my awesome entry point, in this case, will be duplicated. So we can use another macro. This is a special macro called counter. This macro evaluates to an integer, and every time you use it, it's a different integer. You start with 0 and goes up, 0, 1, 2, 3. So we can use this to create unique identifiers like functions or variable names, so we don't have compiler problems underneath. See how we can use this. So first line, we define like kind of a private macro where you concatenate two strings. That's how you do it with two hashtags. Then you create something that puts together a prefix and whatever is passed as an argument. And finally, you use that to pass the counter macro in. So the end result will be my function 0, my function 1, my function 2, so on and so forth. Now we can use this unique label to define our factories macro. And it will be just the attribute constructor and the signature of a C function with a unique name. Now we can use the factories entry point multiple times, and we just put the DSL inside each of one. And you can have multiple per file or across multiple files in your code base. Cool. Another tool, we love blocks. We like blocks. It's awesome. So you can use them to maybe pass bits of imperative code into your DSL. So actually writing a DSL for setting a property to the current date wouldn't make much sense. You cannot cover all the cases. So it's OK to pass a little bit of imperative code in, that you can store this. So what this does is when the event terminate occurs in this state machine, this will be executed before. So in this case, you will store the date that the account was terminated before it actually terminates. Another use of blocks could be to give context. This is actually how you define a factory in this tool I was mentioning. And they give a structure, they give context to what you're trying to say. In this case, we're trying to say, hey, this is how you will bake a fake user, right? And there are other techniques that are being used in the example I want to cover really quick. For instance, we're using ObjectiveC scripting. It could be a useful tool for DSLs. And internally, this is using also KVC. Good to know. I just want to mention that. And you can use block for context, not only with methods, but with the entry point that we used earlier. So you have the state machine, and so you don't have to worry about how to instantiate a state machine. You will get it through the block. What else? Categories. Oh, categories. Really powerful. You can add methods to any class. This is, again, Kiwi. It adds the method should to NSObject. It doesn't actually add should. It's a longer method. That's a macro. But effectively, you could say that. So now you can call should on any object that you have. Now, this is OK because it's a testing tool. But again, adding methods, it's powerful, but it can also be dangerous. So handle with care. Now, I want to mention that this technique plus method chaining is a big win. Now you can have DSLs being born out of arbitrary objects. It could be quite powerful. Another tool I want to cover really quick is scopes. Let's say that you have, for instance, a property that's an NS data formatter, and we want to lazy initialize it. Now you don't want to write the getter every time you want to make a lazy initializer. You can create a macro that does something like this. It writes the implementation for you. The first argument will be what's the name of the property that you want to lazy initialize, and the second will be how you actually construct that object the first time that you call this getter. Now, the problem with this is that the second argument seems like it only takes one line. What if I actually want to set the format date, the date format, sorry, into the date formatter? Well, we can use scope for this, and scope is as simple as open curly brace, close curly brace. You can put this in any point of your method, and it will create a private scope where you can define variables inside, and it won't be visible from the outside. And the last line of this will be actually implicitly returned out of the scope. So we can do something like this, where this is not a block. We're just using a scope, and note how at the end of it, which is returning the variable. So this will be actually evaluated as the second argument of this macro. Now, you can rely on this for your DSLs. Another thing is what's called syntactic sugar. You can basically add connectors that they make no difference in the semantics. They don't change what this is doing if you omit them. But it can add this fluidity to your DSL. So you can add things like with or and, et cetera. Cool, moving on. So again, this is the entry point of Nocilla, entry point of the DSL, the first particle. And it takes two arguments, right? The method and the URL, and they're both strings. Now, I mentioned earlier that we should rely as much as possible on the type system to, to make our DSL less error prone. So you enforce with the type system the valid things that you can say. In this example, we have one problem, though, is that we can, for instance, pass nil as the URL. It will compile, but it will cause an error later on. And this applies to DSLs or any API, really. So we can use this small trick. You can annotate this method or C function with this attribute, and this will add a compile time null check for this argument. And if you actually pass nil, it will give you a compile error. So this is a simple trick. So if we have now this function declared as this, sorry, I have to wrap it. Now when you pass nil, it will not compile. OK. What else? Yeah. So again, two strings. And I want to add a feature to this project. And that is that instead of passing just a string as the URL, so it matches a full URL, I wanted to be able to pass a regular expression. So if you have a URL, your code is going to trigger an HTTP request to a URL that you don't know exactly how it's going to be, but you know most of it. You can maybe pass a regular expression to match it with that. Now, you can pass strings, but what do we do if we want to pass regular expressions? I know this. I just change it to ID, and then we can pass strings. We can pass regular expressions, and it works, and it's awesome. The problem is that we can also pass an array, and we can pass an NS object, and it will compile, right? So how do we avoid this? Well, we can add a protocol to an existing class. And basically, if we want to only accept strings and NS regular expressions, what we do is we define a protocol. In this example, would be something like matchable, something you can match against. And with a category, again, really powerful tool, you add this protocol to NS string class, to NS regular expression, and you go with only the classes that you want to accept as part of DSL. Now, what you do is you change the signature of the method to, instead of accepting a string or ID, you take an object that conforms to your protocol. And this only will accept NS string and NS regular expression. Now, we can only say valid things. We can pass strings, we can pass regular expressions, but we cannot pass arrays of objects or anything else. So it's important we cannot pass these things. So it's important to rely on the type system as much as possible to limit the things that we can say so they're only the correct things. OK, what else? OK, seems like it's time for me to shut up. So I just want a quick recap. A DSL is a thin layer on top of an abstraction or semantic model. It's important to separate both. It has limited expressiveness and domain focus. That's what makes DSLs worthwhile. So you can make your code more maintainable by using DSLs, improve developer happiness, improve the communication, and write fewer bugs. So that's all I got. Thank you.